Today we are gonna graph some quadratic functions. So a quadratic function, as you hopefully know, is anything that can be written in the form ax squared plus bx plus c, like that one for example. So anything that is degree 2. When you graph it, the shape that it makes is called a parabola, kind of like that little U shape that you can see right down there below. Every parabola has an axis of symmetry, which is a vertical line that divides it equally into halves, and it passes through the vertex. The equation of the axis of symmetry is x equals negative b over 2a. Your parabola is concave up if it opens upward, like this one that we have here. It's concave down if it opens downward or bends downward, like one that's reflected over the x-axis would be. Those vocabulary words apply to different kinds of graphs as well, not just parabolas. So let's look at this graph. First, we're supposed to give the coordinates of the vertex, which if you just look at the coordinates of that point that I drew there in green, it's at -3, -4. Your equation of your axis of symmetry, that's the vertical line that goes right through your vertex. So it should be x equals -3 because it consists of all the points with x values of -3. Your x-intercepts are where it crosses the x-axis, so those are at -5, 0 and -1, 0. The y-intercept's a little bit harder to find because we can't exactly see where it crosses the y-axis. I mean, it's sort of up there somewhere, but we don't know exactly. To figure out exactly, think about the fact that we know our x-coordinate is 0. So if we take the equation that we were given for this function and plug in x equals 0, we'll get our y value out that goes along with that x value. So we're going to end up with 5. So it's going to cross the y-axis at the point 0, 5. And this one is concave up because it is bending and opening upwards. Now we are actually going to graph some quadratics. You always want to find your vertex first. So the x-coordinate of your vertex is x equals -b over 2a, which, if that looks familiar, it's the quadratic formula without the radical part. So on this one, since b is 0, we're just going to have 0 over 2 times 1, which is still 0. We need the y value, plug y equals 0 into x squared, and you get 0 out. So a vertex is just at 0, 0. This is the parent function for quadratics. Your axis of symmetry is always the vertical line through your vertex. Drew it in and labeled it as well. Now we need some more points. So it's a good idea to do 2 additional points that are close to your vertex. So don't pick like x equals 5 or 15. They won't fit on your graph. Let's do 1 and 2. 1 squared is 1. 2 squared is 4. So if we plot those, that's half of our parabola. We can reflect them over our axis of symmetry to get the other half. So just count out the same distance away from your axis of symmetry and then connect it. So there's y equals x squared. Let's do one that is a little bit more complicated than your parent function. You always want to start with the vertex, so get your x-coordinate by doing x equals -b over 2a. That'll give you -8 over -4 is +2. That's not the full point though, so to get your y value, plug that x-coordinate back in and simplify. So order of operations, square 2 gives you 4, and then I can multiply things together and end up with, let's see, 2 for my y-coordinate. So my vertex is at 2, 2. Plot that on my graph, draw in my axis of symmetry to remember where the middle is. Now I need some additional points. So if I pick some x-coordinates that are close to my vertex so that they're likely to fit on my graph, that's ideal. I could do like 3 and 4, or actually, you know what, it'd be easier to plug in 0 and 1 on the other side. So let's do 0 and 1. Plugging in 0 just gives us -6. If I plug in 1, let's see, 1 squared is 1, I got 8, 6, so I'll end up with 0 there. Plot those. This one is kind of a tall, skinny, reflected parabola because it's got that -2 on your x squared. So it's concave down. It looks like that. We are also asked a follow-up question. We're supposed to solve 0 equals 2x squared minus 8x plus 6 using our graph instead of the quadratic formula or any of our other methods. So if we're looking at it graphically, we're looking for points that have our y values equal to 0. So if I can find the points that have my y coordinates equal to 0, those corresponding x values are the solutions to my equation. So let's go up and find the points that have y values of 0. They are those 2 points in blue right there. Those are the points 3, 0, and 1, 0. So they've got the y values of 0. When y is 0, our x's are 1 and 3. So those are the solutions to that equation. And those are also our x-coordinates of our x-intercepts, or what are called our roots of our equation. In addition, they could also be called the zeros of this function. Lots of words to describe that idea. So just like absolute value functions have a maximum or a minimum value, quadratics do as well. So if you're thinking about the shape of a graph that would have a minimum, it has a lowest output or a lowest y value that it reaches. So a parabola that's concave up is going to have a minimum. And if it has a highest y value it reaches, then it's got a maximum, like the y's go no higher than that. So equations that correspond to those, anything that has a positive coefficient on your x squared term is going to open up and have a minimum. Anything that has a negative coefficient on your squared term is going to open down and have a maximum value. So we can use that idea to find maximum and minimum values for quadratic functions. It's easiest if we have a graph, but we don't have to absolutely have a graph, because if you look at that, it always happens at your vertex. Okay, so I can see right away this one has a minimum value, and its minimum value is the lowest y value it reaches. So it has a minimum value of -4. And we like to specify where that happens at too, so I'm going to say when x equals -3. This one I don't have a graph, but if I find my vertex, I know that my minimum or maximum value is going to happen there. So let's do x equals -b over 2a, which if you plug in, we'll have opposite of -2 over 2 times -1 equals just -1. I need the y value though when we're talking about maximum or minimum, so plug it back in and simplify. Squaring -1 makes it positive, but then you have the negative outside. Let's see, we end up with 0. So our vertex is at -1, 0. Let's decide whether 0 is our maximum or our minimum value. So if you look at that coefficient on your x squared term, it opens downward because it's reflected across the x-axis. So if I drew a little sketch of it, it would look something like that, with my vertex there at -1, 0. So this has a maximum value of 0. My height of my parabola goes up to 0 and stops, and that happens when x equals -1. Okay, this is kind of a complex one. So we basically got this music store, and they're trying to figure out if they should increase the price, actually it says price of their songs. But if they increase the price of their songs, they're going to sell fewer. We're trying to figure out what would maximize their revenue. So you're kind of given a function. Their revenue is the amount they charge per song times the number of songs they sell. If you change that to, in terms of this situation, it's $1 plus however many 5-cent increases times however many songs they sell, which they're selling 4,000 right now, but they'll lose 80 songs per day for every price increase of 5 cents. If I want to think maximum revenue, that's going to be the highest point on my graph of this function. So I need to find my vertex. This one isn't multiplied together in standard form, so I can't do x equals -b over 2a until I multiply it together. So if I multiply this all out, it's gonna give me 4,000 and then minus 80x plus 200x minus 4x squared. Combine my like terms and then maybe reorder it so that it is in the order that you're used to. Then it's set up so I can use x equals -b over 2a to find my vertex. So if I do that, I'll have negative 120 over 2 times negative 4, 15. And then I'm going to have to plug that back in. I made a mistake. I had to go back and fix it, so I won't make you re-watch all of my work in between. But hey, I got 15. I plugged it back in, and I got 4,900 out. So think about what X stands for. X is the number of 5-cent price increases. So the number of 5-cent price increases that's going to maximize our revenue is 15 5-cent price increases from the price I'm at right now. If you look at what I got out for my maximum revenue, it's a maximum of $4,900. So if we answer the question, what should they do to maximize their revenue? They should increase the price of their songs by, if I take 15 times 5 cents, by 75 cents to maximize their revenue at $4,900.